All right, guys. So some of y'all are still needing to finish the Chapter 9 test, and there will be time after today's notes to do that. But there is one section of 9 that we're going to cover that we didn't cover before the test, and that is 9.7. Now, part of 9.7 is dealing with law of sines and law of cosines. That was on the notes or your vocab sheet that you did find those, but we didn't cover it because I wanted to do it separately. Now, what we're looking at today is using some of our trig functions, looking at angles greater than 90, as well as finding areas of a triangle. Now, so far we've actually calculated these here, sine, cosine, tangent of a given angle, and they still have values even if it's not between 0 and 90. So the first one we can look at is tangent of 150 degrees. Well, if I want to find it, we can just type it in, and we would get what? Tangent of 150. So negative square root of 3 over 3. So it does have a value. Here it just works out for tangent of 150 degrees, it's negative. We can do the same thing for sine of 120 degrees. And if we find its value, we get square root of 3 over 2. And I mean, we can do the same thing for cosine of 95. And we would get 2. And we do get a specific value for each one of these here. Now for sine, cosine, and tangent, when we get these bigger angles, positive or negative, there are some that we do need to be careful with if we're taking it the other way around. Because, yeah, those were the answers. So we could do the same thing for 1, 2, and 3, but let's look at sine of 60. What is the value for sine of 60 degrees? But isn't that the same value of sine of 120? So this here we do need to be careful for going the other direction, because if I took sine inverse of square root 3 over 2, it actually wouldn't get me back to 120. It would actually tell me that it's 60. Because again, these values for sine, cosine, and tangent repeat each other. And the same thing is true for tangent of negative 30. Because it's based off the sine, cosine, tangent functions, which, because sine ends up repeating itself. And it oscillates between 1 and negative 1. The same thing is true for cosine. And it actually works out tangent of negative 30 degrees is actually negative square root 3 over 2. Which is the same thing we got for tangent of 150. Tangent, yes, thank you. Which would be the exact same thing we got for tangent of 150. So there are spots where they repeat, and we go a lot more in depth in this in the trigonometry class and pre-calculus class of how these work and what we would need to do to go from the correspondent of the side lengths back to the given angle based off of where it's at. Now, it's pretty much, it's considered above that, but it's really algebra 2 with just a few things added in. Okay. Now the rest of the lesson today is looking at area of a triangle. Now the area formula for a triangle, area is equal to what? 1/2 the base times the height. Which for a right triangle, the base and height are the two legs. So if it's a right triangle, the base and height are those two legs. But if we look at this triangle here, is that a right triangle? No. So this area formula works well if it's a right triangle. If it's not a right triangle, I have to actually figure out what the height is, dropping a line down from an angle to the other side to make a right angle with the opposite side, and then being able to find it from there. However, if we're given two side lengths and an angle in the middle, we can actually find the area of the triangle using these formulas here. So for any given triangle, A, B, C, A, the area is equal to 1/2 AB sine of C. Or we can say the area is 1/2 AC sine of angle B. Or we can say the area is equal to 1/2 BC sine of A. And all three of these formulas are actually saying the exact same thing, because we have 1/2 of the two sides times sine of the angle in the middle. Because BC sine of A, side length B, side length C, sine of A. 1/2 AC sine of B. A, C, B. Well, the last one we have is side lengths A and B times sine of C. 1/2 times the two side lengths times sine of the angle in the middle. And this right here will give us the area of the triangle every single time. So here, if I want to find the area of this triangle, well, we do have two side lengths and an angle in the middle, so we can actually use this formula. So we can say the area is equal to 1/2. Well, our two side lengths are 17 and times sine of because if we're given two side lengths and an angle in the middle, we could say 1/2 times those two side lengths times sine of the angle in the middle. So on the calculator, we can say 1/2 times 17 times 19 sine of 135. That's it. So we have 114.197745. If we round to the nearest tenth, like it asks, so it'd be 114.2. That's it. That's all we have to do for this here. Any questions on this here? All right, let's look at the next one. Now again, on this triangle, we're given two side lengths and the angle in the middle. So the area formula tells us that we have 1/2 times one of the side lengths times the other times sine of the angle in the middle. And at this point here, we can plug this in to the calculator and get our answer, which would be and that's it. That's all we have to do for this here. Any questions on any of this here? This is the last one we'll look at. Now, is the angle between the two sides? It is. Well, if it's hard to tell, there's an easy way for us to figure it out. Draw a picture. So it tells us that this is triangle ABC. All right, I'm going to pick this as A, this is B, and this is C. I just picked those three angles to be A, B, C. And it works out that the side lengths opposite angle A, side length opposite angle A is denoted as little a. Side length opposite B is denoted as little b. And side length opposite C, angle C, is little c. And this is actually a standard way to label any figure. And it works this way on every single test in every math class. They do it this way. The side length opposite the angle is just a lowercase of whatever the angle's letter is. And all the angles are always capitalized for their lettering. Now it told us that angle B is 60 degrees. We know that side length A is, and C is. Okay, so the angle is in the middle, so this does work. And we can say that the area is equal to 1/2 of 19 times 14 times sine of 60. And again, at this point here, we can just type this straight into the calculator, and it would give us, what is it? 115.2. And that's it. That's all I have to do. So especially if you're trying to find the area of a certain region, or if you're wanting to paint or do stuff like that, this is kind of nice, because as long as I know two of the lengths and the angle between them, we can figure that out. Now, are there any questions on this here? Now, most likely, if you're actually trying to find the area of a triangle, finding that angle in the middle is probably not as likely that you're going to carry around a protractor and have something as accurate as that. But what is the likelihood that you would have a triangular figure that you're trying to find the area for painting or doing whatever with it, but knowing all three side lengths? Well, that's more likely, yes? There's actually a way that we can find its area without having to figure out what the height is and measuring that out, because most of the time the height isn't going to give us a nice whole number. It can be ugly sometimes. And it works out that Heron's formula that he came up with and works for the area of any triangle that we have three side lengths for is that the S value is all three side lengths together divided by 2. So the first thing we do to find the area, given all three side lengths, is we add the three side lengths together and divide it by 2. And then the formula itself is S times S minus A times S minus B times S minus C. And we take the square root of it. Now, 10 years ago, I mean, doing this here would be less accurate than actually trying to find the height of the triangle, because actually taking the square root of something is not quite as accurate. But with the advancement of technology, we can actually do this pretty easy, because most of us now actually carry a calculator in our pocket. So we can actually do this here. Now, looking at this first one using the formula, the first value we need to find is S. So we can take the sine length 7.5 plus 8 plus 14 and divide it by 2. And this value of S will always be bigger than any of the side lengths. S will always be bigger than any of the side lengths. And now we just need to plug it in. So we have the square root of S, 14.75, times 14.75 minus A. Well, which side length is A? And then we have 14.75 minus b. And b is? And 14.75 minus 8, because that's the last side. Now, did it matter which one I put in for A, B, and C? Well, no, because we're subtracting it from our 14.75 for each one. So as long as I have all three sides included, we're good. Well, 23 point. Let's go 2.7. We agree with that? Inches squared. It's just our units. Because in the calculator, we can say second square root, 14.75, 14.75 minus 8.75 minus 7.5, and 14.75 minus, and we get the 23.27. I think it was 268. It'll be easier to use the arrows. 7.5. Yep, it was kind of buried in there. Yep, but that's all we have to do for this here. Questions on this? Let's look at one more. Now this time we're going to include the side length of 14 twice. Why is that? Because there's two 14s. So we'll have 14 plus 14 plus 13 divided by 2. It's 28. Yep. Because it's 37 or 34.5. Because 3, 4, 4, 3 and 4 is 7, 1, carry the 1, 41. Let me see. Plus 13. That does work, but if we type it in that way, because 14 plus 14 plus 13 divided by 2. The issue that this has is our order of operations is parentheses, exponents, multiplication, division, left or right, then addition, subtraction, left or right. So what the calculator is going to do here is going to divide 13 by 2 first, which would give us 6.5, and then add the other two numbers to it. Now, if you want to do it that way, there's a way we can do it. We just put a parenthesis first, 14 plus 13, close parentheses, divided by 2, we'll do it. Because the parentheses is what it's forcing it to do, is to simplify everything inside it first, then to do the division of 2. And that's how we get the 20.5. Now that we have that, our area is equal to the square root of 20.5 times 20.5 minus 14 times 20.5 minus 14 times 20.5 minus 13. And at that point, we can just plug this into the calculator, and it'll give us our answer. Questions on this here? Do we need to see another example of one of these? We like these? Well, if we feel good with these here, that's all we're doing today.